Hello and welcome to Unit 1 of Grade 11 Academic Math. Our first unit is Algebraic and Numerical Expressions. And a lot of this is going to be review of some things that you might have seen in Grade 10, but also pushing them a little bit further. And really, for now, it's all about trying to work with polynomials. And in our first section, our first lesson, we're going to be looking at how we add and subtract and multiply those polynomials. And again, hopefully some of this will be review. So when we see a word like simplify, it means taking a more complex looking algebraic expression, something like we have in question A here, and finding a way to quite literally make it simpler. And we can do that by combining together any like terms. And remember, like terms are any terms that have the same variable attached and the same exponent on that variable, which also means that if some numbers don't have any variable attached at all, they can be collected together as like terms as well. So let's try an example together. So for this one, we've got a polynomial in one bracket, and it's being added with a polynomial in another bracket. So one thing we could do is imagine that there's a positive 1 sitting in front of this bracket, and distribute a positive 1. And when I say distribute, I mean multiply positive 1 by each piece inside of the bracket. As soon as I do that, I can rewrite my next step without brackets at all. And when this is a positive 1, in other words, the brackets being added, this becomes a fairly straightforward process. So it would be 3x squared that I already had, plus the 7x I already had, and plus 1. And now I could just add 2x squared minus 3x minus 5. And then I start to identify any like terms that I can find. So I can see here that I've got 3x squared and a positive 2x squared. I've got 7x's and negative 3x's. And I've got a positive 1 and a negative 5. So let's combine those together. So when I put the purple ones together, that's going to give me 5x squared. When I put the greens together, well, 7 subtract 3, positive 4. And then 1 subtract 5 is negative 4. So minus 4 is the last term that I'll add in there. So that process hopefully was review for you, and that one is a pretty straightforward example to start with. Let's get slightly more complicated in our second example. So I'll bump over to B here. And now it looks very similar where we've got one big bracket and another big bracket, but now the second bracket is being subtracted. But the idea is the same. Instead of this subtraction symbol, think of it like a coefficient of negative 1 in front of that whole bracket, and multiply negative 1 by each piece inside of it. And that distributing step is going to make sure that we get our signs correct. So we rewrite the 5x squared minus 2x minus 3 that we already had. And now this is where I have to be careful. I'm going to have minus 3x squared minus 6x and plus 1. Really, you can see what happened there is that the sign of each term that I had inside that second bracket just ended up switching to its opposite because I multiplied them all by negative 1. And now I'm not going to get all colorful when I collect my terms anymore, but I can see that I have 5x squared and subtract 3x squared, so that would be like 2x squared. I have negative 2x's, and then I subtract 6x's, so that's like negative 8x's. And I have negative 3, and then I add 1, so that's going to give me minus 2. Now, if you do find it helpful to color code these and underline the like terms in different colors like I did in that first example, you're definitely more than welcome to do that. But I'm not going to be doing that in each example that you see, because once you've seen it once, I think you guys know how to do that. So aside from just adding and subtracting these polynomials, what are some other little calculations and operations we might have to worry about? Well, you can see in example C, now we're getting into some square root signs. So if we're square rooting something like this monomial here, it's got two pieces to it. It's got a coefficient of 25 and an exponent with a variable with an exponent on it. Well, the 25, what we're going to do with that coefficient part is just literally try and take the square root of it. So in this case, it's just equal to 5. To take the square root of the variable part, the x to the power of 6, just take whatever exponent it has, and square rooting is really just going to cut that exponent in half or divide it by 2. So this is going to become 5x to the power of 3, or 5x cubed. Now there's nothing I can do with my second term right now, so I'm just going to rewrite it, and we'll do some combining and deal with it in our next step. So minus 6y squared. And then, well, x squared and y squared combined, but then I square root each of them and I just get x and y. Because again, I'm cutting each of their exponents in half. I still have minus 7x cubed. And now I follow my rule for this last one. I square root the 9 to get 3, and I cut my variable's exponent in half, so it must be minus 3y squared. So if I look carefully, I'll notice that there's 2 terms. One starts with a 5 and another with a minus 7 that each have an x cubed attached. So when I combine those, I would get negative 2x cubed. I also have 2 terms that have a y squared attached. So if I take negative 6 of those, then I subtract 3 more of those, I would get negative 9 y squared. And then I also have this extra plus xy. Now, often though, just as a convention, if we have a mixture of variables, we often tend to separate them. So the y variable that's on its own in the second term there, we might write that term at the end. So you'll often see it written something like this in its final form, where the one that has a mixture of variables would go in the middle, and the ones that are just individual variables, like the x cubed and the y squared, those just can go on either end. Let's see how we would approach this next one. Again, thinking about square rooting. Well, now once again, we want to square root everything inside of that first square root symbol. The square root of 49 is just 7. And then we've got this bracket here, x minus 2, and then the whole thing is being squared. Well, that means if I square root that entire thing, that's really just going to get rid of my squared. So I end up with just the x minus 2 in brackets beside it. So that bracket had a squared on it, but the act of square rooting got rid of that squared. Those were opposite operations that canceled each other out. And in a similar way, this piece that I'm going to subtract is really just, well, the 3x plus 1 in brackets there was being squared, but then square rooting it eliminates that squared. So I really just have this bracket 3x plus 1. And now I can apply my distributive rule that this minus needs to multiply by each of these. You won't necessarily see me do that every time from now on, but that's a good thing to remember. And I can remind you that we're also going to do that with this 7 while we're at it. So 7x minus 14, subtract 3x's and subtract 1. Combine my like terms together would give me 4x and minus 15. Let's keep going and see how this expanding and simplifying process can go a little bit further even. So now, once again, I need to use my distributive property. So 2x squared needs to multiply by each of these. And then, careful, negative 3x squared needs to multiply by each of these. Once we get an expanded form, we'll start to bring things together. So this is going to be 2x cubed plus 2xy minus 3x cubed minus 12x squared y. And just correcting myself here, I missed one here. This is actually supposed to be, 2 times x squared y when we multiply those out, because remember there was already an x squared here, so when I multiply it by the y, we end up with x squared y. So that was just my little mistake there, and I caught it just before we moved on. So that's an important little mistake that I caught, because now actually we do have just two separate groups of like terms. So we have this group with an x cubed attached. I'll combine those to get just -1 of those, or negative x cubed. And then I have two that each have an x squared y attached. So if I start with 2 of those and I subtract 12 of those, I get -10 of those. So -10 x squared y. And that's the final simplest form that I can write that in. We'll do one more of this type, where we're just expanding and simplifying. So again, before I go and use anything with this very outer 2, I have some stuff inside of these square brackets, and I need to sort of expand from the inside out. So I'm going to take this 2 first and multiply it by each piece that I have inside, and this -2 and multiply it by each piece that it's attached to here, which means that I'm not actually going to do anything with the very first 2 out in front just yet. And I could actually just switch to regular brackets, but I'll use square brackets just to remind you that these are the same square brackets that I had before. But I would get 8x plus 6 from that first set of orange expansions. And then I would get -2x and plus 2. Now, again, before I do anything with the 2 on the very outside, I should make everything inside my square brackets as simple as possible. So I'll keep my 2 on the outside for now and say that, well, my 8x and my -2x become 6x, and +6 and +2 become +8. And now I can actually expand and multiply everything by 2. So that becomes 12x plus 16 in its final form. For the next portion of this lesson, things get a little more complicated. So if we look at something like example 2a, now just to review a little bit of terminology, what we have here is an example of a binomial multiplied by another binomial. So what we mean by that is this first thing inside a bracket has 2 terms to it. Remember, that's why we call it a binomial. The bi part means 2, and it's multiplied by another bracket that has 2 terms in it. So it's 2 binomials being multiplied together. When that's the case, we have special rules that we have to follow. Essentially, each term inside one of the binomials has to be multiplied by every term inside the other. So in other words, if I have this 3x squared, it has to multiply by this 2x squared, but it also has to multiply by 5. But at the same time, this -1 has to multiply by 2x squared, and it also, as well, has to multiply by that 5. So we'll actually end up expanding this out into 4 separate terms, and then possibly grouping them together and simplifying it from there. So what does that really mean? Well, 3x squared multiplied by 2x squared is 6x to the power of 4. And then we would have plus 15x squared, and then minus 2x squared, and then minus 5. Those are just the 4 pieces I get from doing those 4 little orange arrow multiplications that I demonstrated. But now what you'll often see happen with these situations is that the 2 middle terms in this case happen to be like terms. They can be combined together, and so my final slightly simpler form of this is 6x to the power of 4 plus 13x squared minus 5. Let's see a slightly tougher example now. We'll build up these skills. So now we've got an added wrinkle thrown in. We definitely have a binomial multiplied by another binomial, but then we also have this additional term out in front of the whole thing that we need to multiply it by. Well, the key with these is to think of this whole thing as if it's got its own extra set of square brackets. So it's always best to do the multiplication of the binomials first and get that into its simplest possible form, and then we'll deal with that -2 out in front actually at the very end. So for now, what we're going to do is just keep the -2. I usually say we're just going to bring it along for the ride. We're just going to keep it out in front, but not do anything with it just yet. With the stuff that was in those square brackets I created, let's show what we would actually get. Well, x times 2x is 2x squared. I would get minus xy from the next multiplication. Then I would get positive 6xy. And I would get minus 3y squared to finish it off. And again, I could multiply negative 2 by everything if I wanted to at this stage, but I can do this a little bit easier if I first simplify what I have inside. So I'll keep the negative 2 along for the ride for now. And I can take my 2x squared and leave that there, but now I can combine those two middle terms inside the bracket. So positive 5xy. And I still have my minus 3y squared. And now I take my negative 2 and I multiply by each term inside my square bracket. That's going to give me my final simplified form. Plus 6y squared, like so. So those are the basic skills, and really at this point you've now learned all of the basic important skills that you need, but as you'll see, these things can get stretched out into longer and more complex polynomials from here. So let's just do two final examples to tackle those situations. So here is a great big long one for C, and I'm actually not going to do every single step. I'm just going to get you started, hopefully make sure that you're on the right track, and then allow you to try and finish it off independently. So with this one for C, a couple things to be aware of. And actually, before I do any actual calculations, I'm just going to rewrite this in a slightly different way. So this here says 2x minus 1, and then that whole bracket is being squared. We have to remember that squaring something means multiplying it by itself. So if an entire bracket is being squared, that means that entire bracket has to be multiplied by an identical copy of that exact same bracket. And I'm actually just going to rewrite that to make that a bit clearer for myself. So here I'm going to say it's 3, and then I'll use a square bracket just to separate this out a little bit, times 2x minus 1 multiplied by another 2x minus 1. And then I'm going to be subtracting that with whatever I get when I eventually expand this out. And then I'll subtract 2 times whatever I get when I expand this one out. So I'm just adding some extra square brackets too, for the same reason I added some extra square brackets in the previous one, really just as an additional reminder of the best order to do this stuff in. So let's start to simplify. So here we have 3, and then inside my square brackets, I would have 4x squared minus 2x minus another 2x plus 1. This one would be 3x squared plus 3x minus 4x plus 1. And this is going to be minus 2 times whatever I get in this last one. I'll give myself a little more room, which would be 9x squared plus 3x minus 3x, and then minus 1. So before I do any multiplying by anything in front of my brackets, I can simplify some stuff inside of each bracket. So let's write this a little bit simpler now. So this would be like 3 times something like this in a more simplified form. This would simplify out like so. And this third big bracket, it's going to be minus 2 times 9x squared. And then we had plus 3x and minus 3x. Those actually eliminate one another, and we just have 9x squared minus 1 inside that bracket. And now I'm going to leave that for you to try and finish off. So really all we have to do is expand each of those 3 separate brackets out you'll end up with this great big long list of terms, and then you'll need to regroup and simplify those terms based on like terms. Let's just do one last example together. And I'll just point out, for example, see, once you've finished trying it for yourself, remember that the full completed versions of these notes are always found in the material that I post online for you. So you can always go and check the completed version of this note to make sure that you've finished off and solved this one correctly. But let's just talk about a few last details with this question D here. So now we've actually got a trinomial being multiplied by a, well, what looks like a binomial, but this binomial itself is actually squared once again. So to deal with that, I'm going to start by doing the same little trick that I did before, which means I'm actually going to just rewrite this first trinomial as is. And remember, I call it a trinomial because there's 3 terms in it. And I'm going to represent that squared by rewriting the x plus 2 right beside. And now what I'm going to do is put those square brackets that I've been using around those x plus 2's, because I'm going to use my expansion rules first to expand that out, to multiply those 2 binomials together. Which means, again, for now, I'll rewrite my trinomial. I won't do anything with that just yet, because what we always want to do is try and simplify any binomial multiplication that we can find first. So here, be like x squared plus 2x plus another 2x plus 4, or in other words, again, I need to rewrite this, but inside my square bracket is x squared plus 4x plus 4. So now, what I actually end up with, what I'm really doing from this point on, is multiplying a trinomial by another trinomial. Well, we actually apply the rules in the exact same way. In other words, each of my 3 terms in my first trinomial has to multiply by each of the 3 terms in the second trinomial. That's actually going to produce 9 separate terms if we do this correctly. So that's going to expand out, and you can pause it at this stage and try this on your own and then check mine after, or just work along with me here. But I got x to the power of 4 plus 4x cubed plus 4x squared minus 2x cubed minus 8x squared minus 8x plus 4x squared plus 16x, and I even need a little bit more room, and plus just 16. From there, I leave it as an additional final little challenge for you to regroup and make that into its simplest possible form by finding any of the groups of like terms and by putting those together. Once again, you can always go back and check the full filled-in version of this note to make sure that you've finished off questions C and D correctly. And make sure as soon as you finish those that you're working on the homework that goes along with this lesson.